The question we're dealing with is what's the domain of some function? And we have two options. Either it's all reals or it's all reals except. And those exceptions for now are given restrictions, division by zero, even root of a negative number, physical limitations such as time, distance, area, relative to word problems, and other restrictions. When we get to logarithms, for example, we'll have restrictions, but we're a long ways from logarithms now, so our main concern will be the given restrictions, eliminating the possibility of division by zero, eliminating the possibility of trying to take an even root of a negative number. Well, our task is to identify the domain of f of x equals x squared plus 3x minus 4. And so we have a couple of questions to deal with. Are there any variables in the denominator? And there are none, so there is no possibility of division by zero. Next, are there any variables under an even radical? And again, there are none, so there is no possibility of taking an even root of a negative number. So then the domain is all reals. In set builder notation, we would write D equals the set X element of the reals, script R, close the set. Now for B, we're given a restriction. We've got the same function, 3x minus 4, with the restriction that x is greater than or equal to 0. That is the domain then. So now in set builder notation we have D equals the set X such that X is greater than or equal to 0. Here we have the function f of x equals x divided by the quantity x minus 3. There's a variable in the denominator. And if we let x become 3, take on the value of 3, then that denominator will become 0, and division by 0 is undefined. So therefore, we have a restriction. And so the domain is x such that x is not equal to 3. So in words, that means all reals except 3. For D, we have f of x equals the square root of 4 minus x. And clearly we have a variable under an even radical. So here's how you handle these. You set whatever expression happens to be under the radical, you set that greater than or equal to 0 and solve for x. So we'll subtract 4 from both sides of the inequality, and then we'll multiply both sides of the inequality by -1. And in doing that, -1 times negative x is positive. When we multiply through by a negative, we have to flip the inequality, and -1 times -4 is 4. So now the domain equals x such that x is less than or equal to 4. And we are done. For the function f of x equals x divided by the quantity x squared plus 3, we have a variable in the denominator, but that variable is squared. So whether we put a positive value in for x or a negative value in for x. When it's squared, it will become positive. Therefore, there is no way that denominator will ever be 0, and consequently, we have no restrictions on the domain. The domain is the set of all real numbers, or the set x, element of the reals. For f of x equals the square root of 4 plus x squared, and we have a variable under an even radical, but that variable is raised to the second power and added to a positive number. So there is no way the expression under the radical can ever be negative. And so again, we have no restrictions. The domain is all real numbers, or as in script notation, we'll say the set x, element of the reals. And we're done.